This way my voice echoes more so
Welcome, welcome, welcome. How's everybody doing tonight? Good. Welcome to MySec Southfield, the best MySec in Southfield that you've ever seen. Welcome to all the new members or new attendees. We're going to have a great talk tonight. So my name is Brett Hansen. I'm the Southfield coordinator. If you have any questions, concerns, feedback, just let me know. I'm on Slack and you can ping me. For those who may have traveled out of the area or may work in different areas, we have several different MySecs. We have MySec Jackson, which meets the second Tuesday of the month. MySec Lansing, which meets the second Wednesday. MySec Southfield, which meets the second Thursday. Welcome. There's also ISC Squared, North Oakland ISSA, Motor City ISSA, and Lansing ISSA. If you're interested in attending any of those events or those regular meetings, just let me know and I can pass you the information. So we're currently meeting at Town Square Food and Spirits. Please pass your thanks to the service staff that have provided this room and great service. And also thank you to Tech Systems for providing the food and the snacks that we have here for the event tonight. So be part of MySec. If you have a topic for a talk, let me know. Or if there's a talk that you would like to see, let me know. We'll see if we can reach out to the people that have those skills and we'll get them up here to share their information. If you would like to give a talk, see me. And if you have not joined IRC or Slack, visit mysec.us and there's a link at the bottom of the page that takes you to both. I think a lot of people have kind of migrated over to Slack, but if you're an IRC fan, they're still integrated, right, James?
Yeah, it's just got a lot of spam.
Okay.
That's becoming.
All right.
Yeah, join Slack.
Join Slack. That's the message. I should probably get rid of that. Okay. So MySec Social, the location is to be determined, but it's going to be Thursday, August 30th. It will not be in Royal Oak because there will be Arts, Beats, and Eats. They'll be closing down the streets, so we're going to find some place hopefully close to it, but yet still enjoyable. We'll throw it up on the website and, of course, tweet it out for everybody so that you know where it's at. There is a MySec barbecue at Kensington Park August 26th from 12 p.m. to 4. Be there or be square. It's going to be really cool. Friends, family, and everyone is welcome. Come on out and have a great time. GERCon is September 6th and 7th. If you haven't purchased the tickets, they're still available. And DerbyCon is October 5th through 7th. They're currently sold out, but sometimes you can find tickets online. And I know there's a lot of groupies that just show up for the parties. So if you're interested in going down there, those are the dates. Also, join CDH and Microsoft for a summer security sweep. There are still 2 sessions open. I'll post a link back into the Southfield channel at MySec. I wasn't able to make it this week, but it sounds like some people from MySec went, and it was actually a really good event to go to. So look out for that link, sign up, it should be really good. Is there any job postings that anybody would like to do announcements for? Anybody hiring? Anybody looking for a job? All right, so Tech Systems really helps out with this location.
Yeah, I know Andrew.
Okay, yeah, Andrew, a great person.
Pretty much everyone else in Tech Systems.
Okay, excellent. And I spoke to you too.
Yeah.
Blue Cross is going to be looking for some people as well, so keep an eye out for some postings there.
What are you going to do?
I'm a blue teamer, cybersecurity, basically the controls engineer, so antivirus, SIEM technology, setting those up, that's what I do.
Cool.
Dominantly.
We're definitely looking for support people at Blue Cross. Okay. Other announcements? Anything? CTFs? Anything special like to share? All right. And also, okay, that's it. So we have the talk title today, which is Data Science and Infosec, and we have Pwnables. Going to teach us some really good security.
It's a generous assumption. Oh, perfect timing, Brett.
It wasn't me.
You really needed that eye patch.
Right? All right, so while that's coming back up, I know Brett mentioned that there's some new people here. I apologize that this is your first talk. I promise they're normally more entertaining and more about hacking. So as is usual for talks like this, before we dive in, you have to do the whole rigmarole of who am I? So my name is Brian. I go by Pwnables. I'm not actually in Infosec yet. I don't have an education in Infosec. I haven't worked IT. I'm just looking to transition. Since college, where I got my background in economics, I have worked as an associate marketing scientist, an intelligence analyst, a web analyst, a product developer, and as a data scientist, but they are all the same thing. It doesn't really matter what you call it. If you're messing with data, you're a data scientist. A little personal note, I do cuss a lot. I'm going to try to keep it clean for the talk, but if something slips out, I apologize. It's not meant to offend you. And of course, the official. My job does not support this. They don't know that I'm here. So, shh. So what are we hoping to achieve here? It's basically the 4-step process. Step 1, quit your bullshit. 2, let's explain it like I'm 5. 3, step 4, profit. So what does that mean? First and foremost, what kind of prompted me to want to give this talk is not just in Infosec, but kind of data science as a whole. Machine learning and AI are taking over to almost be synonymous with data science, to mean that like that's just what it is. And that's just a bold-faced lie. That's a small facet of it. Data science is an analytical mindset. And what I want to try to show today, by describing what it is, how you do it, what it looks like, is to actually demonstrate that it has a lot in common with hacking, right? And we'll get into what I mean by that. And then once we kind of break that down, like show those similarities, I want to start showing the actual data science workflow and start giving you, hopefully giving you some ideas as to how you can start incorporating that into your work on the blue team. And then, of course, profit. So let's dispel the propaganda. I don't know if this video will actually play, but as hackers, we, of course, have always seen how they do it on TV.
For weeks I've been investigating the can-be-killer murders with a certain morbid fascination.
This is in real time.
I'll create a GUI interface using Visual Basic. See if I can track an IP address.
That sounds great. I love it.
That's accurate. What?
So let's break this down. She builds a GUI in Visual Basic from scratch to track an IP address when she could have used Google. And this is how television portrays hacking, right? TV, movies, etc. It's the same thing with data science. Like, if data science was actually cool to put into a movie, it would be all those same buzzwords. Like, we're going to solve this problem using deep neural networks and machine learning and etc. And it's all just the same garbage. It's this overcomplicated solution to a problem where a solution that's much more simplistic already exists. And so back in, I believe, 2001, when data science was described by the Harvard Business Review as like the sexiest job of the 20th century, this guy Drew Conway came out with this Venn diagram to say, okay, what is a data scientist? What is data science? And so the way he broke it down was 3 categories: math and stats, substantive expertise, right? You have to know your domain. So for data scientists, as it was described then, it was more about knowing your business, so the company that you work for, what are their needs. And then hacking, because a lot of times the data that you want or need isn't being given to you. You have to get out and take it. So what I want to do is compare a data scientist to a hacker and just kind of see what are those actual similarities, right? So first and foremost, we're all just analytical and curious, right? A lot of us got our start by just wanting to know, how does this work? How is it supposed to work? What happens if I do something to make it work other than the way it does work? So by that nature, we're driven by questions like how, why, and what if. How does this work? Why does it do what it's doing? And what if I change something? So depending on a data scientist's daily tasks, you're going to find that there's a lot of similarities between blue team or red team, right? So for a data scientist who is mostly kind of munging data or getting it all cleaned up, or just like going through data that they already have, it's going to be more blue team, right? You're inundated with alerts. You're trying to reduce your false positives. You're trying to find the real needle in the haystack as quickly as possible. That's going to be more blue team. For some data scientists who get a little bit liberal with what they think they're allowed to have access to, they might go out and scrape all of the profiles from an OkCupid website and start running some analyses on that. And so even though that data is out there, you don't really have access to that data. It's not yours to use. And so that gets a little bit more red team, as you will. And so as data scientists, we generate hypotheses a lot. And so our goal is to come up with an answer, normally to try to predict future outcomes as more data comes in, but also understanding the past with the data that we have. But we don't always have that data that we need. So we'll do things like create sandboxes, generate our own data, build our own tools to parse it out, extract the data, do what we need to do. And we also have to understand how software works, especially now as most software starts to incorporate various algorithms that data scientists are writing. We have to know how that all interacts with the rest of the software that's being built, who gets exposed to what, what's happening on the back end, what's happening on the front end, what are the inputs that are going to be fed into the model, et cetera, et cetera. So a lot of similarities there. And so if it is the case that a data scientist and a hacker have this much in common, then what does it look like to hack like a data scientist? And so, again, this is mostly aimed at the blue team, but what does this mean? So in doing that, it's all about thinking fast and iteratively. We have a large amount of data that we have to get through, and we have to come up with answers yesterday. And so in the company that I'm in now, just for the one specific project that we're working on, we have over 400 terabytes of data. And that's across 1,000 different tables. Some relate to each other, some don't. And so when somebody comes in and they ask a question and they're like, hey, can you tell me about this? You have to be able to say yes very, very quickly. And I imagine it's the same thing when you're working in a SOC or any other security role. Somebody comes in and they're like, hey, we just heard about this. Is this present on our network? You need to be able to get in and figure out if it is or is it not. And so what that means is mining through heaps of data. And in order to mine through heaps of data, what you're aiming to do is look for patterns and edge cases. And that's time consuming. It's hard, especially when everything is just either a log output, which is just a flat file text, whatever, you have to read line by line. That's garbage. What I want to do is show you how visualizations help consume large amounts of data and start to immediately tell stories that allow you to move more iteratively and more quickly through your stuff. But it's also the case that, from what I've gathered in talking to people, when you're working in your SOC, you're kind of at the mercy of whatever IDS or IPS you have, whatever SIM you have. They're going to dictate the format that your data is in. That's the format of the data that you have to work with. As a data scientist, it doesn't work like that. I'm going to take the data that you gave me, but I'm going to put it into a format that works best for me. That might be a flat table, it might be a relational database, it might be a network graph. It could be JSON data, which allows my hash maps. Whatever the case may be, I'm going to dictate what that's going to look like. And so I need to know how to get it from the data or the form that it's in to the form I want it. One thing that often goes underlooked is overlooked, underlooked, both, is that data, once it's collected, people are under the assumption that that data can now tell you everything. And that's a lie, right? Far more often than not, the data that you're collecting either A, isn't posed to answer the questions you'd actually want to answer, or B, is just missing the data that you need to answer. And so being able to realize what that data doesn't tell you is just as important as realizing what it does. So of course you want to establish your hypotheses, right? You're running through, you're trying to figure it out. You want to know what's going on. And then of course, everybody's favorite, debugging. Because when something goes wrong, you need to fix it. So because I said visualizations help consume a lot of data, everything I just said is basically summed up here. This is what it means to kind of hack like a data scientist. The workflow starts with importing your data, making it tidy, clean, so that it's ready to be used. And then you go into this loop that just ends when you have a story to tell, where you transform your data, visualize it, model it. Because of the bashing I just gave to machine learning, we're going to replace model with analyze. Sort of the same thing, but it gets us away from doing any type of predictive analytics. But, excuse me, once you have a story, you're ready to communicate it. And what we're also going to show is that that communication should be automated and should be fun for the person who's about to receive it. Because who sat in a meeting with a presentation that sucks? All of you, it's happening right now. So when importing the data, where does it come from, right? As a data scientist, I've had to deal with data in a whole slew of different formats. Flat files, of course, comma separated, tab separated, pipe separated, any other kind of separated. Markup files, I think all of us are familiar with XML and HTML. Email, having to go through and kind of walk the structure of an email file to pull out all of those and transform it from the format that it's in the email into like more of the tabular format that everybody's used to, because when you're dealing with attorneys, they want it in Excel. Image files. I did some work trying to determine if we had a test image, could we bounce it up against other images and find those that either had similar faces or similar backgrounds to see those that were similar. Databases. You have to know how to at least connect to every database out there, because you never know what somebody's running on the back end. And once you figure it out, they're mostly all the same, but it's the nuances that'll trip you up. JSON, of course, is a common one. And so how do we, and APIs, right? So like, how do we get these data? So like I said, it's either given to you or you take it. And so with the taking side, things like web scraping, sometimes, especially lately, websites have gotten smart, and so it's not just static sites that are coming to you, they're all dynamically generated. So luckily, there are web developers who like to kind of automate the testing of the websites that they build, and so there's this thing called Selenium that helps them do that. But, fun fact, it also helps you scrape the website. So it's been hijacked a little bit in terms of its purpose, so I've used it to go in and get dynamic data where possible. But sometimes you really just have to go down to the JavaScript and use that to extract the data. And we'll kind of look around and play with some of these. So when I was putting the slides together, I was like, oh, should I go through and discuss how to read in all of these files? No, that's awful, because programming languages have done all the work for you. So this talk is going to focus a lot on R. I know that in the Infosec community, Python and Go, thanks to PyCat over there, get a lot of talk. R is great, in my opinion, for when you're running analyses that you want to show to somebody. So what we'll see towards the end of the talk is the types of reports that can be built with R. And so keeping it all in one environment, I think, is perfect. And as you can see, R makes it super easy to just read in all the different files that you'd want. You want JPEG? Read JPEG. JSON? Read JSON. The names are confusing. I understand if it takes a while to learn. The databases here, like I said, because you have to understand how to get into it, you have to understand what the DSN is. You have to understand what your connection strings are going to be if those are needed. You have to understand if there's service names or anything like that. So it can get a bit complicated, but hopefully it's not so much so that you can't get it set up. Where the real fun comes in is where you have to actually get the data yourself. And sometimes this is still done with a wrapper. So say for APIs, there's a package called Tweeter. So if you want to just scrape tweets off of Twitter, you literally just say, search tweets, MySec, and it dumps it in for you. And then as long as you know how to parse that into the proper format, you're good to go. But with APIs, it's not always so simple. Maybe there's not an API available or a wrapper available for the API that you're trying to interact with. So say, for example, you wanted to download all the crime data from December of 2009 to the present for the city of Detroit. You can do so with the URL, right? And it's there for you, but you just have to understand what that is, and you have to understand that the question mark is what starts accepting the parameters, and then knowing what those parameters are and passing that all in. And I'm sure Green Jam could talk about how to manipulate those parameters to try to get you more than what you'd actually expect. But where it gets really fun is where it doesn't actually have an API at all. It really just has a form for you to fill out. And so because you want to do it programmatically, you as a data scientist learn how to go in, extract the parameters of the form, set those up yourself, and then programmatically pass them in via a curl post command to get that data back out. And this is where the hackerish side came in, right? I don't think that most people developing the form on the website expected people to programmatically go in, extract the parameter names, fill them out, and then pass data in to just bulk download their database. But as data scientists, we need it. And so I mentioned that I would show a couple examples. So with Selenium, this is the one that will automate what you've got going on. So if we just run this and let it go, praying to the demo gods, you'll see that it opens up a new Firefox window, goes to Python, goes up to that search box up there, do it, types in PyCon, hits enter, loads the page. So I didn't have to do any of that. I just had to tell Selenium, here's what I need you to do. I need you to mimic a user on this website. Go there. Because now, since we're mimicking a user, what's happened is that the page source has now all been populated with the elements that we need. I can now extract the page source and then parse the results that way. Whereas if I had tried to dynamically go to a page, all I would get is like the JavaScript elements. Or if I had like tried to curl a page or anything like that, it would just be the JavaScript elements. And so while we're here, let's go ahead and go to this site. So I had a friend who wanted to get involved in cryptocurrency. He was like, hey, I'd really love to have all of this data. Can you get it? And so I was like, yeah, web scraping shouldn't be a problem. And so I was looking at it, and it was a problem. It wouldn't come out. And so let's go ahead and maximize. Let's go into our terminal. Oh, Scratchpad is gone. Give me 1 second. So let's go there. Just let me do what I want. I get that it's a concern. Apparently I have to do it here. All right. So we insert our payload, which I'm realizing now is incredibly hard to see, but essentially what we're going to do is we're going to create a new A element, right, a link. We're going to create that, attach a function to it, the download function. We're going to tell it the data that we want, which we're actually just extracting. When you go into the actual talk, you'll be able to see it, but here we're using JSON or JavaScript to get into the actual data itself that's feeding the chart. And we say that we want that, we run it, and then, yeah, I get it, cookies, Jesus. And then, that should have run. What did it not do? There should be, I would have thought, a link that said download data. And of course it didn't work. So this is where the debugging issue becomes important, because now you need to know why it doesn't work. And so as demos go, that one's not going to work for us. But what would happen is that link would be there, and once you click it, you get the download prompt that says, do you want to open this or save it? And if you just open it, it's all of the JSON data from all of the graphs that are on there. And so, and here you can see the string or the code a little bit more cleanly. But that's just another method. Yeah?
Maybe you could even look at the network 10 on that, and that might actually just give you the raw JSON that you're getting, because sometimes it's what you do, you just pull it from the back and it's just raw JSON. So.
And see, that's why us data scientists have to hang out with you hackers. I didn't know that. Yeah, so that was the solution that I came up with, was I want this data, let me just add this JavaScript to the DOM on my end, execute it, and then click it. And of course it just didn't work. So what are you going to do? But let's actually start getting into some of the more useful stuff. So all of us in our jobs have data, we want to use it, and XML and HTML, our markup languages, are often pretty common ones, right? But when you look at those, so if you've ever just curled a web page and get it all back, it's all nonsense. Like the tree structure itself is nice, but regular text parsing does nothing to like get in and try to pull that out. What you want is an actual way to interact with the elements themselves and let those be recognized as entities. And so there's two common ways to do that. XPath is the more general form. XPath will work on both XML and HTML, and it allows you to access nodes at certain points within. So looking at those, so you can just straight up say, you know, I want all divs in the XML that I'm getting back, and that's going to pull all of those elements out for you. And so in doing so, you can either start at the root node, so these are just like all of the top level divs that are not children of something else, or you can say with the double slash, you say it doesn't matter where the div lies in kind of the family tree structure of the DOM. I want all of those divs now. Once you start working down your tree, you might want to start referencing the current node that you're on. So say you've worked your way down, you went to a div to an unordered list to a list item, and you want that to be the current thing because in the next step you want to reference the parent. And so the dot and the dot dot, which we're used to seeing when doing our directory navigation in the shell, those work kind of the same way here. And then at allows you to do attributes. So instead of trying to navigate all the way down, like, oh, I want a div and then a paragraph element followed by, you know, an A-link, maybe that A-link just has a very kind of unique class given to it, and you can just jump right there. The whole point of showing this is that in trying to iterate through your data, you want to be able to understand how to quickly get it out into the format that you need it. And the XML is hardly ever the format that you want it in because you can't analyze it that way. So this starts to get you out of it. So let's look at some examples. So like I said, we're going to go // div. And what that means is I don't care where the div is in the tree structure of the DOM or the XML, I want that element. You might also say, I just want the paragraph elements that are children of the div element, right? So if there's a P element standing on its own, that's probably malformed HTML, but it's not going to grab them. It has to be a child of a div. But let's just say that all you're trying to do is grab links from the web page that you're on, or even the XML if you have it. So you just say, just give me all of the hrefs, and those are going to come back. And now you get to use the links in kind of this vector format. So you just have a list of links as opposed to this labeled designated tree structured XML, which becomes much easier to work with. And again, maybe you're on a Wikipedia page and there's 3 different tables on that page, but you just want the one table that's talking about movies. So you're going to say, give me table anywhere in the page, I don't care where it's at, but it has to have the class movies on it. And so that's going to give you just that one specific table. And from there, now you're even closer to just having your rectangular formatted data. So the other format is CSS selectors. And so anybody who's built an HTML web page before, you know you can add your ID, you can add your classes, you can add different attributes, and we get to use those to start extracting the data. And so again, you have kind of common operators that get you what you want. Node name is the same. Just say, oh, I want a div. You just use the pound symbol to get ID. Those are typically unique per element if it's put together right. Using a period will get you the class. Class can be applied to any number of elements, so you have to be careful with that. You can preface the period with a specific type of element. So say you want all tables with a specific class, you could do table dot, assuming that that class is used on other things. And then the caret, or greater than, depending on who you are, will select children. So if you select an element and you've got kind of nested, so say you select a div and there's just nested paragraphs, but you only want the direct children, that greater than symbol will give you that. So again, some examples. Again, just the simplest one, just say I want all divs. The hashtag article grabs anything with the ID article. Again, on a single page, that should just be one element. P.result will grab all P elements with the class result. And then UL greater than LI, first child. So one thing I forgot to mention was the colon, which allows pseudo selectors. And pseudo selectors are very nice. So what this last one says is find all unordered lists, find the first list item in them, and give them all back to me. And so that avoids the situation where if you had multiple unordered lists with multiple sub-items, of having to like go in and then parse out the ones that you wanted. This says I just want the first from each. So again, I have another example where this was back from my days when I was at the DA's office. I wanted something that would allow me to quickly read through the news and start finding news articles that were important to me on a daily basis. I was looking for machine learning and terrorist financing. You might be looking for ransomware, malware, etc. So what does this look like? So if we curl right? That's not fun or useful. That doesn't tell us anything. That's just the entire web page. But if I run this script here, where you can't see it, but you can get a snippet of it in the actual presentation. Tidy Reuters is a script I ran in R, and we run. Man, that is really awful to see on there, isn't it? Does this make it better?
You should be able to right click on the terminal.
Yeah. That's a little bit better. So what we've done is we went in to the actual web page itself, found all of the news articles that were on that page, extracted them out, parsed them, and then started getting some of the data that we might actually care about. So some of them are common, site and date parsed. I'm just keeping track of that to know where it came from. But then we have the title. That's dynamically pulled from the link itself. I can now search through that and look for keywords that I'm interested in. The next column is the lead. That's just kind of your initial paragraph that tells you what the story is about. I'm going to mine that too for keywords. And then the last one is just the URL, so I know which link to follow if I'm interested in that story, to grab the entire article itself and parse that. And so through that, it's a very simple script. Again, let's just go back here. I say simple, that shouldn't say that. That's coming from the years I've put in doing this. It'll take some time to get used to. But basically, what we're doing is you start with the URL and you want to read HTML, right? We said that R was simple enough. It just gives you a read function for what you want to read. Next is where we get into those CSS selectors I was talking about. So as you follow down, if we say, okay, we want the stories, well, by looking at the DOM of the web page, I was able to start identifying the classes that Reuters was using to style their web page and use that to pinpoint the items that I wanted. So looking at it, feed item, I want that. That's a little card that's holding all the story. Now, stories is my new object. I'm kind of reorienting myself. Links, I'm going to go into that feed item, and I'm going to look down further for an H2 element that is directly followed by an A link. And I'm going to use that A link to pull out the attribute href. And so now what I've done is taken this HTML code and I've extracted out that one piece of text that I wanted. And I'm going to do the same thing for titles, except instead of getting the attribute href, I'm just going to read the text. And then for the leads, I need a different item using a different CSS selector. But through that, I again just take the text and I have everything I want. So relatively straightforward, mostly all done on the back end. I get to use these simple functions and not understand how it works. But I get the data that I want, and now it's in my format. We saw that it was in that rectangular format. I can now go down through those columns, do some text mining on them, and figure out what I want, as opposed to trying to parse through the entire web page that came back. Yeah?
This is R, correct?
That's correct. Yep. All of the code that you'll see in here is R, except for the Selenium and JavaScript. Those were Python and JavaScript, respectively. So now we get to the bread and butter of what Brett wanted me to talk about, regular expressions. People have a love-hate relationship with these. There are people who will play like Regex golf to try to get the most complex search query with the shortest number of bytes in your Regex string. And there are people who just like hate it and write out garbage and they just never want to look at it again. I'm on the love side, but I don't play golf with it. But Brett wanted me to talk about this because it really is super, super powerful, but also super, super difficult. And the only reason I say that is it's very easy to write regex. It's very hard to read regex. So a lot of people describe it as write once, read never. It's almost never commented in code. So I've gone back 6 months later and had no idea what I was trying to extract, even though I was the one who wrote it. So you can kind of see these labels that I have up here. Regular expressions is a language in and of itself that takes special characters, regular characters, etc., and interprets them in certain ways. So the first is quantifiers. And what this is used for is determining how many of a specified character you want. So we'll get down into the characters in just a second, but let's say I'm looking for just the letter A, and I want to find 0 or more A's. The string could have no A's, it could just be the letter B, or it could have a bajillion A's. I just want 0 or more. Question mark limits it to just 0 or 1. The plus, 1 or more. The NM within the curly brackets is where it gets a lot of fun. Say that you have bounds. It can be anywhere from like 3 to 6. N and M are both optional as long as 1 is present. So if you exclude N and just do comma that many, it will go up to that many. Same as doing 0 up to M. So character classes are, for the most part, shortcuts. So /W is all your word characters. And this is where regex gets a little bit hard, because what does a word character mean? You might think it just means capital A through Z, lowercase a through Z, and that's not right. It's capital A through Z, lowercase a through Z, 0 through 9, and a couple special characters, which is stupid. So be careful with it when you're using it. /D is a little bit more intuitive. It's just your digits, 0 through 9. /S is white space characters. That's not just a space. I believe it also incorporates new line, tab, things like that. But the square bracket allows you to enter into custom character classes. And so anything between 2 square brackets that is listed in there becomes your new character class, things that you're looking for. But you have to keep in mind, so what I'll see a lot of people doing is like, they might be looking for the word owl, and so they'll put the square brackets and they'll type OWL, and that's it. That's actually looking for an O, a W, or an L, not the word owl. And so what you're going to come back with is potentially it'll find the word owl because it found the O and it's going to return that whole string and you got lucky, but it's not doing what you think it's doing. This is why I say that it's a little bit tricky. But custom character classes are super nice. Positional characters are also nice. So you say I want to start at the beginning of the string. This is good for forcing the regex to start where you want it to start looking. By default, I believe it always starts at the beginning of the string, except in Python. You have to be careful in there. So some people get used to using the caret to like force that it has to go from the start of the string, meaning that like the match has to start at the beginning. You can't find a match in the middle. But if you run, I think it's match, re.match, even without the caret, it will only match your regular expression from the beginning. What you'd actually want to find a substring in the middle is re.search. Again, there's just a lot of things that really turn people off from regular expressions because there's so many gotchas. And then $sign just says, look for this pattern, but I want that pattern to be at the tail end of the string. The last character has to be that end string character. Lookarounds were fun once I discovered these. This is another one where I believe you have to be operating within a regex engine that is Perl compliant. I don't remember or for sure, check into that. But they're not allowed everywhere, especially with your look behinds. They get real pissy if you have a variable length pattern. So say for example, you're looking for a B that is preceded by an A, and there could be any number of A's prior to the B. You would want to use the positive look behind to say, find a B that's preceded by any number of A's, but it'll yell at you and say, that's variable width, you have to tell me how many A's I'm looking for. I don't have time to get into all the different tricks and how you get around that. Basically, you'd want to use a non-capturing group to list it out. It's this whole thing. Brett and I are in talks of having a much more robust regex type of thing. I didn't want to just talk to you about it, so this is going to be more CTF based. Should be a lot of fun. Stay tuned for that. But we do have some special characters. One more? No. So remember when I mentioned that the square bracket will put you into a character class. So /D will give you the digits 0 through 9, but say for example you only wanted the digits 2 through 7, you can do your special custom character class, the number 2, the hyphen, and the 7. The hyphen within that will become a range character for you and allow you to specify. You can do the same thing with letters, and I believe it works with special characters as well according to like the ASCII table, but I haven't confirmed that. So the question mark we saw earlier meant 0 or 1 of something. But when paired with another quantifier, the question mark coming second, so with the star will eat up as many characters as it can. And in doing so, you might get more than you bargained for. So you can tell regex, hey, slow your roll, we don't need all that, by adding the non-greedy quantifier. So you can do like a dot, which will give you any character, followed by a star to say give me as many as possible with a question mark, followed by some other condition that tells it how to stop, and you get your non-greedy. The caret, again, we saw was start of string, which is always true, unless you're in a custom character class, again, with those square brackets, that will then negate anything you list. So going back to the owl example, you had your square brackets, OWL. If you put the caret in there first, that will then return to you anything that is not an O, W, or L. So kind of double meanings with the symbols, whole lot that you can do with it. Wanted to show another example. So if what do we got in here? There we go, we've got auth.log. So if I just do, yep, a little bit better. So this is just a snapshot of my auth.log file that I took. And if I look at that, it seems at first glance that that might almost be easy enough to parse, right? Maybe I want to just like separate it by spaces. But in looking at it, we know that with August 8th, there's 2 spaces between there because it needs to pad for 2-digit days. So already we're at a variable width separation. Already it's starting to sound like a task for regex. And then as you go down line by line, so that top line, we're looking at like system login, right? Followed by square brackets with I imagine, what is that, my PID? Somebody help me out here. Yeah. I don't know. Colon, and then a description. So that seems like it'd be relatively straightforward, but that's not always the case, right? We have these different patterns depending on the type of event that's being logged in my auth.log. But I want that in a tidy format because I want to mine through that very, very quickly. So I write a nice little script. Tidy my auth log. It runs through, and lo and behold, I've been able to extract the date. The time is its own field. Who was the user that was logged on? Now, of course, it's me every time, right? But we're going to go back to the script and realize that I didn't actually look for me. I looked for things that were valid Linux usernames. We extract the process out. We see that some of them have the PID, some don't. So another step might be that once you have that, you're going to separate that out to get the PID if it's available. And then we have a description that we can go through and either further parse from there or leave it as is and just do some mining from it. And again, all of this is just to get us into getting the data into the format that we want. Speaking of format that we want, I don't want this so big. And so if we go back here, these are the regular expressions that I used. Again, write once, read never. So the first regex here, the AFJDNOS, is A, missing something, which I realized earlier when I was shit posting in Slack. B is what's extracting the date for me. So I know that the date is going to be a capital letter that references a month. And what I'm missing is the letter M, because March and May are months. And so I won't find those. But you can see how I use the custom character class, and it's looking for any one of those letters. I'm then looking for lowercase letters, A through Z, but only 2 of them. I need there to be 1 or more spaces, followed by 1 to 2 digits, right? That's my date. The next one, kind of straightforward. 2 digits, colon, 2 digits, colon, 2 digits. That's the time, right? Pretty straightforward on that one, super easy to read. In logs, here we have a little bit of fun. So here we're using what I told you was the positive look behind. That's going to be the question mark left, or less than sign, equal sign. Those 3 characters together say, look behind the pattern that I'm about to, or that's going to be specified outside of the parentheses. So essentially what I'm looking for here is, and this is for the user, so I need any lowercase letters or an underscore followed by any word character, any digit character, underscore, or hyphen. And I need 1 or more of those. And that whole pattern itself should be preceded by a digit and then a space. And so you have to specify that, because otherwise you're going to start getting into, like, maybe you get into the process that's running, or maybe it misses everything and it just runs over to the description. I want it to stop at that user and just pull that user out. For the process, we go lowercase letters A through Z or a hyphen, 1 or more. And then you'll see that, so one thing to note is the double backslash. R is the only language I've come across that needs that. Most of it's just 1 backslash and then your character. R forces you to escape it. So you'll see on this line here for process, I actually need a real bracket. I don't want it to go into a custom character class, so I have to escape that, find some digits, but that's optional, right? So there might be a PID there, so we'll use the question mark to say 0 or 1. And then I want that to be followed by a colon, but I don't actually want you to capture that in a group. That shouldn't be treated as anything. And then finally, we use the negative look behind again. And I'm sure this here just makes sense to everybody, right? Any character, doesn't matter. Any character at all, that's what the period is. The plus says 1 or more, but the question mark says don't be greedy, and then the $ says the end of the string. Now, if we're looking at that and we're like, well, we're just looking at that description, who cares if it's greedy? We want it to just run and run and run to the end of the string. The problem is that that first colon that it finds, I mean, we put the space in there, but that first colon that we see was all the way back in our time. And so if we just did a colon and then any character until the end of the string, it would have gotten us everything after the hour mark in our log. So you just have to be kind of particular about what you're putting in. Yeah?
Is the don't be greedy limited to a certain amount of characters?
Solid question. I actually don't know the answer to that.
Parsed it out, they're all even lengths at the end.
Oh, no, sorry. That is a byproduct of R doing a pretty print. Yep. To the best of my knowledge, it is not limited to a number of characters. So the question was, if I add the non-greedy question mark here, will it restrict and say, okay, you said don't be greedy, I'll only give you 20 characters. It doesn't work like that. It will take as many characters to fulfill the pattern as is necessary, but will take the minimum number of characters necessary to fulfill that pattern. So this is not meant to be read right now. This is a Stack Overflow response to somebody saying, how do I use regular expression to parse HTML? You don't, okay? Warning about regex. When people start learning it, they think that it can save the world. Maybe it can, but it's just not great, right? And so this guy starts going into this entire diatribe and then just starts throwing in prime examples of why you don't use regular expressions to start parsing HTML, because it's the Wild West, like anything's valid out there, right? And so then at the bottom he goes, have you tried using an XML parser? So he gives real advice, right? So there's tools out there meant to parse XML. There's tools out there meant to parse HTML. If you're in Python, use Beautiful Soup. It's fantastic. Don't use regex. There's also a Sans video out there talking about using regex to get into your logs, kind of like how we just went through. I want to talk about that as well and say that always check to see if there's a simpler solution. So the first thing I did when looking at auth.log was confirm that I wouldn't have been able to just parse it simply using a space delimiter, such as like just the cut function on my bash shell. Regex should be your final solution, and there's plenty of XKCD comics out there to tell you why. So a final tidy example before we move on to other things is Bob Rudis of Rapid7 fame. Last year said, hey, the CDC just put out this analysis. They've supplied the data. It's atrocious. And so if you downloaded the XLS file, it was actually XLSX because it was XML on the back end. Excel won't even open it. So you had to like read it in, parse it as XML. And so I don't know. Yeah, I don't have the code. The code will be shared on my GitHub later to view it. It was a hot mess. Like going in, everything was all in one column, but like needed to be rotated out. But like to do so for 6 vaccinations, 53 states, and 7 different years. And so like you had to kind of extract whatever. It wasn't pretty, but it was a lot of fun and gives you a good experience in terms of like what does tidying data look like to go from this dumpster fire that we had to something that was slightly more useful. So transforming data, we're gonna rush through this a little bit. How am I doing on time?
You're good.
Okay. So transforming your data is things that you do in order to make it more usable for your analysis. So just because something comes in some value, say male, female, that might not be the best, right? Say, for example, you wanted to know what proportion of your data was female. Well, male, female, now I have to like count, like do my own math, whatever. Well, if they were 0s and 1s, you just take the mean, right? So the mean of a binary variable will just tell you the proportion of those that are a 1. And then 1 minus that is the proportion that are 0. So standardization is used to ensure that nothing's going to kind of break going in later. So for all of you who do app testing, you might know that if you put in an uppercase input and it's only looking for lowercase, it won't take it, right? So we have to standardize on the back end to make sure that that works. Forcing values to be between 0 and 1. So say, for example, you had a variable like income that can range from 0 to, billions of dollars. That's a lot, right? And those are very large numbers. So what if you just wanted them to be between 0 and 1? 0 was the absolute lowest value in your range of income. 1 was the absolute highest, and everything else just fell below as a decimal. That simple formula right there will get that for you. Removing extraneous text from strings. I've had to do this when I was working for the Detroit Police Department. We wanted to figure out people with like their police records, and so we needed names that matched. And so I don't know how to tie this directly into what you might be doing in Infosec, but say you've got data where the strings are slightly different from each other, but in a predictable way. So here you might have had junior or senior attached to the name, or the name might have had a middle name in some cases, but not in others. You just want to remove that, standardize it so that all fields are as comparable as possible. On the opposite end, maybe you want to add text to complete the picture. There's a great package called libpostal, ironically enough, based on machine learning, that takes addresses and standardizes them. So regardless of the format that the address is in, it will use a bunch of data and try to give you the most complete picture of that address for more concrete comparison. Indicator variables, you see this all the time. Sometimes it's YN, sometimes it's the full word yes and no, sometimes it's 0, 1, sometimes it's 1, 2. Indicator variables should always be 0, 1 for the reason that I mentioned. It makes it much easier to perform statistics on them and run your analyses. And all positive outcomes in a binary variable are coded as 1. I can't tell you how many times people get tripped up, they run a number, it comes out, and they're like, oh, this is great, or oh, this is awful. But in reality, they had flipped their codings, and they're misinterpreting the results that they're looking at. So casting to a new type. This can be helpful when modeling. So I mentioned like the male, female. That's obviously a string, so you have a character class. But it could be better if it's a 0 or a 1 in integer. just allows for better handling. Sometimes, even if I'm reading in data, say from like a CSV, where I know that one of the columns is a date time, but I'm not positive that the date times all follow the same format, say like month, day, year, programs try to be super helpful in terms of guessing that for you, and they'll try to cast the new type for you, but you don't want that. In my opinion, you want to do that on your own. You want to be in charge of knowing why your variables are the classes that they are. It's going to really help you out when you're just cranking through analyses. And just keep in mind that with great power comes great misery. When you're doing all of this stuff, it seems like it's pretty straightforward until you get hit with like a misaligned type, something isn't the way that you thought it was going to be, and then all of a sudden your entire analyses just fell to the ground and you have no idea why. It's the equivalent of missing a semicolon. So I mentioned Bob Rudis earlier. He and Jay Jacobs wrote a book called Data-Driven Security, and I shamelessly pulled a function out of there to use for my own fame. So let's say that you have IP addresses and you want to determine if they're in a range of other IP addresses. So IP addresses, IPv4 by their very nature, are strings, right? Because you have your 4 sets of octets separated by the periods, strings themselves. So comparing if it's in a range is kind of annoying, right? Like you can compare the first octets to each other and then the second, etc. Or you can just convert your IP address to a 32-bit integer and then take the min and the max. So here, let's say that I want to know if my IP addresses are between these two. So let this be the min IP address, this be the max. I'm going to cast those to long so that they are now integers. And then I'm going to cast all of my other IP addresses, which I mentioned earlier, being able to just make up your own data. I didn't have a bunch of IP addresses laying around, so I just made some. So you have that. And now I just want to check, is this IP address, when it's converted to its long number, in that range? And yes, it is. Super quick function, runs almost instantaneously. I've now done my checks. And this kind of ties a bow on all of that in terms of getting the data in the format that you want, being able to iterate quickly, and knowing how to transform your data to get it in the format that you need it. Binning and categorizing data. Binning and categorizing are kind of self-explanatory, I think. Say you've got age, right, or income that ranges, but you want your buckets, right? The Census Bureau does it all the time. In Infosec, we might do it with IP addresses, right? Like we might just want some block of IP addresses that all fit in. So anything that's within those ranges, we're just going to say it's this one block of IP. And so basically, it just involves collapsing data into numerical or categorical groups. So I said, we're going to have these IPs. We're just going to put them into this block. We've now just put that into a categorical. Categorical simply meaning that the data type of the value is a string and not a number. It's great for reporting purposes. So let's say that you have this great graph. If all of your data is on the x-axis, you can really start cluttering it up. But if all of that can just be collapsed down and still not lose the story, that's where you're going to want to be. And so speaking of which, people think I have a really strong opinion on data visualization, and I don't know why. Don't use pie charts. They're awful. Seriously though, people are really bad at seeing the value, like the spatial region of a pie chart. And so when you're showing a pie chart, they say that if you're going to do it with like 3 to 4 values at most. But if you're going to do that, just use a table. It's 4 values. But once you start getting into more than that, it's too hard to actually read and glean anything from it. So people are like, well, I'll just add labels to it. Well, now you're just cluttering your chart. It looks awful. Just don't use them. There's always a better way to do it other than a pie chart. So histograms and bar charts, these get tossed around with some fluidity as just being the same thing. They mostly are. Like, don't let people tell you that they're not. Histograms are used for numeric data, so again, income and age, and they're going to attempt to do that binning for you. So histograms are for numeric data, bar charts are for categorical, so each bar will have a label assigned to it. Again, bar charts, almost always better as tables. unless you've got a lot of different bars on your graph, if you're showing like 6 bars, just show a table. It doesn't have to be a graph. It's okay to show a table. Excuse me. Line charts used to show trends over time. Pretty straightforward. And scatter plots should show a relationship between at least 2 variables. So you have a variable on the x-axis, a variable on the y-axis, and you're really looking to see how those 2 variables play with each other. So does the y variable decrease as x increases? Does y and x increase together, or is there no relationship? Yes?
I can tell you're a data scientist because we've actually received feedback. We don't, the numbers aren't that important, we just want it to look pretty. How many's heard that before?
It sounds superficial.
Table to me is the best way to communicate data.
It sounds superficial, but honestly, if it doesn't look pretty, nobody cares about the story that you're telling. So here's one thing to keep in mind. 3 ways to show attributes. You can use color in your graph, you can use shapes, or you can use sizes. And I'll show an example of that in just a second. Don't try to get super fancy with it though. Don't try to clutter your graph. Edward Tufte, famous informational designer, what have you, said there's no such thing as data overload, there's just poor design. So there's no such thing as too much data on your graph as long as you do it correctly. Keep the color blind in mind. So red-green is huge for people. Keep that in mind when you're presenting to, say, your CISO or outside shareholders, anything like that. Blue-orange, I think, is the other one that gets people. A red-blue combination does a really good job. Ink to data ratio should be minimized. You don't need labels and a box outlining your graph and 4 titles and whatever else. Like, just get your story out there with as little ink as possible. And always label your axes. So there's 2 types of graphs, really. I know that we just went through bar, histogram, line, scatter plot, etc. But the 2 types are exploratory graphs, and these are used for, these are when you're doing your exploratory data analysis. These are just grip it and rip it types of graphs. These do not need to look pretty. These should actually look horrendous. All you're trying to do is just get answers very, very quickly. So the main goal is to help you formulate hypotheses, identify outliers, highlight trends, relationships, the kind of things that we talked about with the different graphs that you would use. And here, I said that you're looking to get answers, but you should really be developing more questions than answers with these graphs. This is your exploratory phase. You're trying to understand the hypotheses you should be generating, the things you should be looking into, trying to figure out where that needle in your haystack is. These graphs should be giving you more questions than answers. So let's look at that. So I downloaded this data set that just had data on people going out to dinner. So it gives things like the day of the week, how much was the total bill, how much did they tip, what was the size of the party, was it lunchtime or dinner time, what was the gender, and were they smokers? Okay, very simple data set, but it serves a nice purpose here. So let's say, for example, I just want to look at, okay, what's the distribution of the total bill look like? Kind of a stupid example here, but I hope you can imagine ways in which you might want to see the distribution of some metric in what you're doing at work. So you just say in R, give me a histogram. It automatically chooses some bins for you, and we see here that most of the bills in this data set are between $10 and $30, or 10 and 20, excuse me, $10 and $20. Okay, well, knowing that, what about tips? Most of them fall less than 4. Cool. So we're looking at that. We know that most of them don't fall above 6. And through that, we didn't have to look at a data set that had 600 lines of data and try to figure that out, or try to go through and figure out whatever. Visualization. It just told us right away. It's very simple. So now you might be asking, okay, well, what's the relationship between total bill and tip? You would expect that the tip would go up as the total bill went up, assuming people that tip 18 to 20%, as the case may be. And we see that that's mostly true, right? If you were to draw a line, it would look something like this, and we see that that's upward trending. So we see that, as expected, the tips go up in accordance with the total bill. Now, why this is helpful is because we had a hypothesis about what tips, the relationship between tip and total bill should look like. So if this was reversed, if we saw that the tip actually went down as the total bill was increasing, first we want to ask, did we actually plot it correctly, right? Don't jump to conclusions and assume that you found something great in your data or something wrong. Assume that you plotted it wrong first. Confirm that it's right. But then once you know that you plotted it right, well, now you found something. That goes against your hypothesis. Why? So what if we wanted to break it down by day, right? We're still looking at the percent, and I apologize for the graph falling off. Maybe if a little bit better. So we're still looking at total bill to tip, but broken down by day. Is there a stronger linear relationship on the weekends? Do we see that maybe on Thursdays, nothing's going on? Now, a good way to use this is imagine that you're trying to look at network activity broken down by day, right? And the way that we do that is we take this facet wrap and say, hey, I want you to use this variable day as a way to break it up. And then the n row is just the number of rows. That just makes it pretty. But the facet wrap says, hey, I want to use this other variable to break this stuff up, to try to look at trends from a more 3D perspective. Well, let's say we want to look at more things. So here, we're going to also add the size of the party. And in order to show the size of the party, we're going to use the size attribute. So the larger the icon, the larger the party that went out to dinner. I want to look at time. So here I know that time is binary, lunch or dinner. I removed the legend. I don't care. Like, this is just for an example. But what we can probably glean just by looking at this is that blue is lunch, right? We assume that more people are going to go out to dinner on Friday, Saturday, Sunday. Thursday's probably more lunch, people that are out for work. So our hypothesis still stands correct. We can see that in the data. And then shape is the sex, male or female. And again, looking at this, if the gender is the people who are paying, I mean, it could really be anything. It's kind of 50-50. Well, more triangles, but whatever the case may be, the legend would tell you who that was anyway. But just by doing this, just by adding some color, some shape, some size, and breaking it into the facet, we now just included 5 different variables in order to look at our data, and it's very easily consumable. We can see that there is still trends on Thursdays and Fridays. Sunday, it's a little weaker. The Sunday crowd doesn't tip as well in relation to the total bill. And you're just able to glean these insights very quickly through data visualization. So this is a GIF that I haven't figured out how to get to just start from the beginning when I get to the slide. But it's basically going to go through this graph that started to get to here. And it's a lesson on how less is more. Okay? So I really like that GIF. I wish I could take credit for putting it together, but it was somebody else. But it does a really good job of showing how less is more. Remove all the ink, remove the fancy stuff, remove everything that's not helping tell your story. Now, also keep in mind that that less is more is for the second type of graphs, which somehow got lost in the slides when I was editing over dinner. Those are your production graphs. Those are the ones that you're going to be using to tell the story to your CISOs, your bosses, your coworkers, etc. Those are the ones that you might put in white papers or on a blog post or on your company website. Those are the ones that you actually want to care about what's going on. Those are the ones that should have a title. Everything that the graph itself should be self-contained. Anything that's needed to tell the story should be in that graph. The source of the data should be captioned on the bottom, things like that. And just you want somebody to be able to grab that graph off of the floor, look at it, and know exactly the story that you're trying to tell. And so the whole point of that GIF was showing that like that less is more. You can tell like how much more easily digestible it was, how much more pleasing it was to look at, how much more receptive people might be if you were to hand that to them. So let's get into analyzing data. There are literally a ton of different ways that you can go about doing this. It's going to change depending on the question you've been asked, the data you have at hand, the time you have, the tools you use, your knowledge, the hypotheses you've already generated, et cetera, et cetera, et cetera. And the numbers are just going to continue to increase as you develop more hypotheses. But all of these ways can essentially be achieved with just a few key concepts, which we'll look at now. So the first one is group by. Group by is just a way to take all of your data and break it out into chunks and start performing functions on those chunks. The best way to describe it is imagine that you had a bag of M&Ms. Bag of M&Ms represents all of your data. Dump that bag of M&Ms, sort it by color. That's your group by. We're going to group by color. And now we might do things like calculate the number of M&Ms that actually have an M on it. The number of M&Ms that are greater in diameter than whatever the average size of an M&M is. We might count the number of M&Ms within there, but you see how we can apply these functions to the different groups. That's what group by is doing. So you'll see here that if we were to take the entire data set, the mean total bill, so the total bill on average is about 20 bucks, right? And the average tip, $3. But what if we wanted the average bill, average tip by day? Simple, just use a group by. And I keep using simple, I don't mean it in terms of like, oh, it's this simple. What I mean is that like by using the group by, it does a lot of the heavy lifting for you. You don't have to think about how to separate all that out and start doing whatever. You just specify how you want to group your data and then the functions that you want to apply to it. Next is ranking. Ranking is exactly what we all know it as, right? Just we want to start with the best and then the second best and the third best, etc. So here, what I'm looking at is broken down by day. I want to rank each bill by how much they spent, with those who spent the most being rank 1, okay? And so I do that. I group by day. I arrange the data within each group. So the largest bill for that day will be at the top for each day. And then I mutate. So I take advantage of the row number function. So now that they've been ordered, row number 1, that's my rank 1. So we'll assign that to rank. Now I'm going to ungroup the data because I want it all back together again. And now I'm just going to arrange by the day and then by the rank. And so what we see, these are obviously all Friday, but you can see that the total bill is in descending order. And so we've ranked it. What does that actually do for us? Right now, nothing, right? That was kind of useless. But the third key concept that you need in order to rip through your data is the ability to filter it. And so say, for example, I wanted the top 3 most expensive meals per day in that data set. Well, I'm able to do that because I ranked the data by day. And so now, all I have to do is go back to that exact same logic that I had, 3 most expensive bills. So imagine that you're looking for the top 3 IP addresses that have been coming in on your box on specific days, or whatever else the case may be. These are the types of things that are going to allow you to quickly get to those types of answers without having to manually look through your logs, rely on your SIM, rely on whatever else. So a few projects that I'm working on to kind of give you an example of what this looks like. A rat in the lab. LANL, the Los Alamos National Laboratory, provided data, and it was actually used in the B-side CTF this year for anybody who participated. So looking through that really gave me some experience. They provided their data in flat files, very large flat files, all comma separated. And so it might seem as though that's enough, but it's not. So one of the things that you might talk about, and this is where that awk statement came from earlier, Pycat, is that when you have repetitive data in your data set, especially if you're about to store 70 gigs of data into a database, querying that takes a long time. And so if you can dedupe and reduce it down so it's not so repetitive, so names in there were so for the name of a user might have been like C10485, and that is of course going to be a string. Strings take up more bytes, and that's going to be repeated for a lot of bytes. Well, if I had another table that said, well, the number 1 represents C, whatever number I just said, And so in the data, anywhere you see a 1, it means that user. Well, now we're down to a small int, right? We're down to like that single bit. And so that's much less data, much easier to index, much quicker to rip through. So that's called normalizing data. And my whole point in bringing that up is that just because data looks like it's already in what's called rectangular format, you got rows and columns and what have you, it doesn't mean that it's still perfect. You can always go further. How close is too close? So when I was working for the DA, we were investigating the shipping company that was sending money to people in the United States, which just seems weird. Why is a shipping company sending money? So looking into it, I found that they all lived within 6 miles of each other. So now you have a question. Is 6 miles legit? If you were to randomly take a couple or 3 people from a city, is it legit that they would live within 6 miles of each other? I don't know that answer, right? I don't know if it's worth investigating. I don't know if it's worth issuing a subpoena to the bank accounts of these 3 individuals, which I'm then gonna have to wait months on, then I'm gonna have to parse it, then I'm gonna have to put it into Excel, then I have to analyze it. I don't know if it's worth the rabbit hole. So I wanna test my hypothesis. Is this random? Is it legit? What do we got? So what I did was I took a similar city, took the geospatial map of it, found the US Census density data for the different census tracts, used those as the weights to randomly sample where to put 3 people in the city, and then used the Manhattan distance to calculate how far away they were from each other, averaged that, and ran that simulation over 1 million times. And then I plotted out how often they fell within 6 miles of each other. And what I found was that 25% of the time it happened. So now, of course, you as the analyst have to determine is, what's your threshold? For me, 25% was large enough that we weren't really going to go into it. I couldn't get the attorneys on board anyway. But my point telling this story is rabbit holes are there. They're going to get you. Have a way to test your hypothesis and figure out if it's worth going down. Yeah?
In school, in theory, I've been taught to generally keep it at like a 5% rate. Do you follow that rate as well in terms of like, yes, there is a correlation here or not?
When you say 5%, are you talking about things like p-value? So that's slightly different from what I'm talking about. A p-value is often misconstrued as a probability in the way that I just mentioned probability, and they're different. The p-value in that sense basically says what are the odds of getting data that looks like this if the null hypothesis were true. And so if it's less than 5%, that's when you want to look into that, right? Here, you could still use the 5%, right? Because that's a low value. So like obviously 5%, pretty rare. But it's more of a judgment call. And it's true on p-values as well. You'll see people jump up to like 10%, mostly to ensure that their hypothesis gets accepted or whatever. But it is mostly a judgment call. I don't normally incorporate it if I'm not using p-values. I'll let it vary depending on the situation. Part art, part science. So yeah. Another one, again, from a tweet by Bob Rudis, was talking about how people that are learning data science will be given a data set and they're like, build us something cool. And so the city bike for New York, the bike share, similar to how we have Mojo or whatever. So analysts will go out and do these grand visualizations and show like the most popular bike stands. And the blog that Bob pointed to said, who cares? Management already knows that. And this is where we get into that idea that just because you have data, it doesn't mean that you have data to answer the questions that are important. So what was missing from that data was what happens if somebody goes up to try to rent a bike and the bike rack is empty? How do you determine the supply and demand of those without somebody actually saying, I tried to get a bike, it wasn't here, whatever. So you go and grab more data. It's always okay to go and grab more data to supplement the data that you're already using. So the MTA has data, the taxi and limousine company has data. So if I'm going to get a bike and I can't find one, I'm probably not walking, I'm probably going to take the subway or I'm going to take a taxi. So can I take data from those two and correlate it to data to show that, because we know when bikes are empty at city bike stations. They report that in real time. So can we take that and correlate it with spikes in increased gating activity or taxi trips to show that there actually was surplus demand at that bike station? Yeah?
Doesn't Uber kind of mess that whole thing up nowadays though?
From what I gathered, FHV, for hire vehicles, I believe Uber gets rolled into that, and so New York has data on that. But if that's not getting reported, yes, that would completely ruin that, because most people probably would go for a ride share like that. So everybody's seen the book, Automate the Boring Stuff with Python, right? But automating the boring stuff, sure, it gives you time to do the cool stuff, but can't you automate the cool stuff too? And so I think everything should be automated, because I want to spend as much time as possible asking questions and getting answers, figuring out why things work, problem solving, debugging. I like that. But things like generating reports, giving answers to the same question every month, going through the same routines and figuring out the same stuff. I don't want to do that. I want scripts for all of it. I want it to be modularized. I want it to be parameterized. I want it to be as dynamic as possible so that when I run it, it's already capturing all of the edge cases. It's already accounting for everything that we need. I don't have to do anything. I just let it run. If you're reporting on things semi-frequently, say once a month, you're just giving a list of like the top IP addresses that have been getting into your honeypot, that should be automated. That, like, there's no reason that you need to actually go in, do the analyses, and copy and paste into some report and hand that off. And if you're reporting it on more frequently or want it in real time, it should be a dashboard. Dashboards are another thing that kind of fall under machine learning, where like everything has to be a dashboard. I'm still pro dashboard. I think they're fantastic. So automate all the things. So what does that look like? Here you don't actually have to see because we're not doing anything. So this is a proof of concept, not meant to actually be anything fantastic. So I wrote a small little script. Actually stole this code. Somebody wrote a dashboard that allowed you to provide inputs. So here we're just going to pick a number between 0 and 100, but imagine this is things like time of day, day of week, month of year, some cider block, whatever that you want. But you have various parameters and you can move them around, right? So let's go back to 50. And we're like, oh, cool, like this shows us really interesting stuff. I want to get this in front of my boss. Boss doesn't like using the dashboard. We're going to generate a report. And here's our report. Can I make that bigger? Always has to be bigger. So that slider bar, that's our parameter n. And we see that it prints out 50. So I didn't have to go in and manually type that. I didn't have to copy paste. I didn't have to do anything. I said generate the report, and it said, cool, you got it. And then it plotted. Using that parameter, it went ahead and just plotted 50 random points as a scatter plot. So let's really drive that home. Let's close out of this. Let's slide that up to 100, just to make sure that I'm not just feeding you lies. So we generated the report, automatically updated. Tells us that the parameter was set to 100, and now we have 100 points. All of your reports should be automated. So that's why I advocate for R, because it allows you to take what's called R Markdown, which is just a play on the actual Markdown. We know how to use Markdown. We're all in Slack. R Markdown allows you to also input code into that, and not just R code. You can do Python, and they're trying to incorporate more everyday SQL, JavaScript, etc. C++ I think is in there as well. And so, that's super annoying. Let's actually watch this in YouTube. So Live Overflow just so happened to post a great video for me. Oh, why am I doing that when I can just do that? Where he was playing Pwnables 3, which was this game developed by Ghost in the Shellcode for a CTF at ShmooCon 2015. So I wanted to show this, right, because this brings us right back into how do I use this in Infosec, how do I make this fun. The game, we're going to kind of skip past it because I'm assuming that we're short on time by a lot. Sorry, guys. And so there was this one part in the game where there were these logical gates that you had to trip by toggling these binary inputs. And the goal was there was this one logical gate at the end that needed to be tripped on to open the door to get the chest and get the flag. It was 32 different inputs, which is a lot of different inputs. And he thought, well, he had already put together a proxy server. He was intercepting all the traffic, so he knew that if he put in some bits, he was also able to programmatically send bits. He didn't have to click all of the different things. So he would just send a string of ones and zeros, and it would trigger. And so he was able to generate like 350,000 different input-output sets. And he's like, well, now I'm just going to do machine learning. He looked at neural nets. He tried decision trees. And honestly, I think he was on a good path. I think that the approaches he was using were great. But admittedly, he said so himself. He's like, look, I just don't know enough. I don't know what I'm looking for. So he backed up. And he went with just a more data analytical approach. And so what I want to show here and use here is to show you, I'm not going to show all of it because it's like a 14-minute video, but I want to jump to the part where he starts using the data analytics and show you what that looks like. So pardon this Hearthstone video.
Let's continue with the blocky puzzle challenge. We identified the packet sent from the server to the client. I did all this over the course of many hours, and so I was handling this trainer data a lot. And one time I thought I could check out how many inputs actually resulted in a desired 0 in one of these output bits. And I wrote this simple loop, just print the input if the particular output bit was 0. I ran this and I couldn't believe my eyes. While the zeros and ones were rushing by, I noticed one column to just stay constant. Look at this. And that turned out to be true for every output bit. Each output bit had at least one bit constant in the input. Now, the inverse of this was not true. Not every input where this was a 1 resulted in this output bit to be 0. But in every case where it was a 0, this input bit was 1. This means our final solution must have these bits set to this constant value. So I wrote a quick script to extract all constant bits, and this is what I got. This really surprised me.
Notice the data visualization.
Every second bit was constant. Holy shit, this is awesome. This also means only 16-bit of 32-bit are remaining. And brute forcing 16-bit, that's easy. There are just 65,000 possibilities left. So I modified the proxy again to, instead of just using fully 32-bit random values, to keep 16-bit fixed and brute force the other 16-bit. And in the packet parser, we can then check if all the important bits are all 0. This means we found the valid input, so I print winner, winner, and just kind of stop everything. So I go in game, start the brute force, and now we just have to wait. I watched some TV show and came back to it like 1.5 hours later, and to my surprise, it was done. It had disconnected, but it found the valid input. So here it is. This is the valid input. Let me log in again and inject the packet with this value. And here we go. Quest complete. Blocky's revenge.
Should have said spoiler alert. So that's just an example of taking those data analytical skills and just say, okay, I've got a bunch of data to mine through. Machine learning wasn't really doing what I wanted it to. How can I actually just take a simplistic approach, some small data visualization, and figure out what I need? And he was able to use it in order to get a flag for a challenge in a CTF. So that's all I have. I say all, but that took way too long. So I can take any questions, or I'm on Twitter, I'm on Slack. I don't want to keep you all here. Feel free to just hit me up on there. But I hope you all enjoyed. want to go home.